Oh, hi, you're back. Thanks for stopping in. This is going to be a short lesson reviewing Z-scores and normal distributions. And for most of you, hopefully this isn't something that you really need because we did do this in class. However, it was the Friday before March break and many people weren't there. And also, I mean, that's just been such a long time from now. It's probably a good refresher. So this is basically a refresher of that lesson. So we need to understand a few things. We obviously, hopefully know what a mean means. No pun intended there. And remember standard deviation as well, which is represented by this little symbol here. Standard deviation, of course, is a measure of consistency or how spread out the data is, how far the data tends to be from the mean. The higher the standard deviation, the more spread out or inconsistent the data is. We also talked about normal distributions. But what exactly is a normal distribution? Well, imagine making a histogram. As an example, let's think about the weight of, say, a female golden retriever, like my dog McGuire here. You say hello? She just wants more food. Okay. We might make a histogram showing the distribution of dogs' weights. And we do little bars like this. And if it happened to be the case that our histogram ended up looking something like this, then we would say that golden retrievers have weights that are normally distributed. What does that mean? Well, in a perfectly normal distribution, the mean and the median are exactly the same and right in the center of the histogram. Also, the data is, or the histogram, the shape of it is symmetrical. Okay? And if we were to take a line connecting the tops of the bars, we would end up seeing this sort of bell-shaped curve. Now, I haven't really given you a very precise definition of what a normal distribution is, but for our class right now, this is good enough to think about the idea of it having symmetry and having a mean and a median that are equal. And what that kind of means is that if golden retrievers' weights are distributed this way, which I think is probably a pretty fair assumption that they are, it means we have a lot of golden retrievers that weigh close to the average and just as many above and below, tapering off to our extreme values here. Now, for the sake of this lesson, we're going to assume that golden retrievers have a mean of 65 pounds with a standard deviation of 8 pounds. Okay, so that means that this is right at 65 right here. And our standard deviation, which is the measure of consistency, is 8 pounds. And we're going to see how we can use standard deviation to answer questions about weights of golden retrievers. Now, remember this notation as well. Summarizing this information right here, we can say n, use that little tilde there, 65 comma 8 squared is how we say that golden retrievers weights are normally distributed with a mean of 65 and a standard deviation of 8. Keep in mind 8 squared, 64, that's what's called the variance, is the reason that we write that way as well. Now, we're going to use McGuire here. She's going to help us today. We're going to record her mass and see how you fit in with these other golden retrievers. McGuire. Now, I already weighed myself, so I know how much I weigh. So if I pick her up and put her on the scale, I should be able to compare her to my weight. Let's just see. There we go. Oh, please. McGuire. Of course, my scale's not working. There we go. Good girl. Okay, McGuire. Whew. Let's see. 74.5. McGuire, you are 74.5 pounds. Okay, we're going to continue this lesson on my computer as we go through some of the math behind this. So let's just take a look at my computer right now. Continuing with our golden retriever example, we assume that golden retrievers have a mean of 65 pounds and a standard deviation of 8 pounds. Now, as far as normal distributions go, that actually tells us we know quite a bit about a normal distribution.
for example, if we take a look at this curve here, which we've already looked at in class, this is a normal distribution curve. Remember that X bar stands for the mean, of the data, pardon me. And that little Greek symbol there, that's called sigma. It's a lowercase sigma. That stands for standard deviation. So in our example, we have a mean of 65 pounds, a standard deviation of 8 pounds. So this little line here refers to all of the golden retrievers that would be 65 pounds plus 1 standard deviation, which in this case 65 and 8 is 73 pounds. So had McGuire been 73 pounds exactly, we actually know the area underneath the normal distribution curve. And we would know that there are only 13.5 plus 2.25. Oops, sorry about that. 13.5 plus 2.25, which would be what? 15.75. We would know that only 15.75% of golden retrievers weighed more than McGuire. Now, McGuire didn't weigh 73 pounds. She was a bit more, so she wasn't exactly 1 standard deviation above the mean. However, using a Z-score and the Z-score table, we can actually look and say, okay, what percentage of golden retrievers would weigh more or less than McGuire based on the mean and the standard deviation that we have. So let's just take a look at below how we're going to do that. So, okay, how much did McGuire weigh? She was 74.5 pounds. Now we can calculate what's called a Z-score. Now don't let a Z-score be too complicated. It's basically the number of standard deviations that you are above or below the mean. So if you're above the mean, you're going to have a positive standard deviation. If you're below the mean, you're going to have a negative. Sorry, let me say that again. If you're above the mean, you're going to have a positive Z-score, and if you're below the mean, you're going to have a negative Z-score. If McGuire weighed 73 pounds, the Z-score would be very simple. It would be 1. She's exactly 1 standard deviation above the mean, but she's not. So how do we figure out how many standard deviations she is above the mean? We take her mass, 74.5, we subtract 65, and we divide by our standard deviation of 8. Now, what do we get when we do that? Let's see, 74.5 minus 65, okay, divide by 8. We get a Z-score from McGuire, rounded. We want to round our Z-scores to 2 decimal places. You're going to see when we look at the table why that is. Her Z-score was equal to, what was that again? 1.19. Meaning that McGuire is 1.19 standard deviations above the mean. Okay, what does that tell us about McGuire's weight compared to that of other female golden retrievers? Well, now you need a Z-score table. So if you don't have your Z-score table, you should perhaps pause this video and get it out now. You can find it in OneNote. You can also find it in the back of your textbook as well. I've got one right here. Okay, you can see that it's on page 399 of your textbook. There are 2 pages. The first page is for positive Z-scores, and the second one is for, the first one is with negative Z-scores, and the second one is with positive Z-scores, which is what we want. So how do we use this? Well, McGuire's Z-score was 1.19. So what we do is we look through the table, and we start with the numbers across the side here. So 1.1, we can see that. Now, each of these entries, this would refer to 1.10 or 1.1, 1.11, 1.12. Now, McGuire's 1.19, so we want to go all the way to the end right here, and we can see McGuire is 0.8830. Now, what does that mean? Well, if you take a look at the top, it tells you the percent or the proportion of the data that is below that particular Z-score. So as it turns out, 88.3% of the data would be less than where McGuire is on the normal distribution curve. So what we can say about McGuire is that she is in the 88.3, what's called percentile. Our wonderful dog McGuire has a mass larger than 88% of the other female golden retrievers that are out there. Now, notation-wise, you'll notice the notation is also up here in your Z-score table as well. We could say the proportion of data less than or equal to 1.19 is equal to 0.883. And this notation, you can think of the P as being either proportion of data, or you can think of it as probability. The probability that a dog, the female golden retriever, weighs less than McGuire is 88.3%. Let's try another problem, slightly more difficult. Suppose that a medical pill for dogs is produced such that it's safe for dogs to take if they weigh between 55 and 75 pounds. What percentage of female golden retrievers will be able to take this pill? So what we need to do is we need to figure out two possible Z-scores. One for a dog that's 55 pounds and another for a dog that's 75 pounds. Let's think of this one as being Z1 being 55 and Z2 being 75. So our first Z-score would be 55, take away 65, divided by 8, which is, of course, negative 10 divided by 8. This is going to give us negative 1.25. Not a surprise that we're getting a negative Z-score for a dog that's 55 pounds. There are more than a standard deviation below the mean. And for a dog that's 75 pounds, 75 minus 65 divided by 8 is also equal to, in this case, positive 1.25. Okay, so now we want to know what percentage of dogs fit into this scenario. So one way of visualizing is to visualize this normal distribution and realize that when we look at our table, we always get a proportion of data that's below that. So we're going to use the table to figure out how many dogs are less than 55 pounds, and then we're going to use the same table to find out how many dogs are less than 75 pounds, and we're going to have to use some logic to kind of figure out what exactly we're going to do to figure out what's in this middle portion here. This middle area is actually what we're looking for. So the first thing to calculate is the proportion that are less than or equal to negative 1.25. So let's use our Z-score table for that. Okay, so negative 1.25 would be on our first page. So negative 1.201234.1056 right there is our first one. That's not a surprise that only about 10.5% of dogs would weigh less than 55 pounds. And finally, for our other one, the probability or the proportion of dogs less than 1.25. Let's just use our Z-score table for that as well. Oops. So 1. There it is. Sorry about that. 1.25. So 1.201234.5. 0.8944. So 0.8944. That's not a surprise either. Shouldn't be shocking that about 89% of dogs are less than 75 pounds. All right, so to find our total, this pill is going to be good for 89.44% of the dog population, because they'll be less than 75 pounds, but subtract the small amount of dogs that are too small. That's that 10.56%. And of course, 89.44. Subtract 10.56 gives us our final answer of about 78.9%. That's our amount of data that's within this range right here, and the answer to the question. Okay, so I hope that this has helped, and don't forget to complete your assignment 3 and hand that in. I'm going to actually give you a sort of a one-question quiz too sometime in OneNote, so keep an eye out for that, and I'll have you answer that for me and use that as part of your grade as well. Okay, thanks. Goodbye for now.